Hi guys, welcome to Algebra Online. Today we are studying lesson 124, which is all about functions. You guys are going to be able to determine if there is a function or not, looking at a table or a graph, and you should be able to describe a function really well after today's lesson. All right, so let's think about a vending machine. I know that we all have gone to a vending machine and pushed a button and experienced maybe it worked, maybe it didn't work, how consistent does it work? And so I want you to think in terms of that a function is a good working machine, okay? And I'm going to reference that quite a bit. So it says number one, to describe the input and the output of this soda machine. But I'm going to back you up. You should have paused by now and kind of wrote some notes down. And I know it might seem weird to write down these sentences in your notes like number one and then write it down, but it's really helpful. I promise you, this knowledge will stay in your long-term memory way longer if you're writing it down and you're listening to me. So try it out. Okay, so what could be the input of the machine? Well, there could be a couple different things. The input could be like the money that we put inside of the machine. It could also represent pushing the button, right? That's the input, the push of the button, and then the output would be the pop. So we could say that it's either or. So let's just go ahead and write that down. It could be the money, or it could be the button that we're pushing. All right. So let's take, for instance, me. I walk up to this vending machine and I push the blast pop. All right, and I got the blast pop. Super cool. All right. And then Mrs. Traver, who is a super awesome math teacher, she pushed the same blast button that I did. And she got a lemon twister. Is this machine working correctly? No way, right? She should have got a blast, and she didn't. She got a lemon twister. All right, so no. And let's go ahead and start to think about it in terms of math. So no, and that means that Wakefield and Traver had the same input. We pushed the same button. But when we pushed the same button, we had the same input, we both got different outputs, which means no worky. It does not work. All right, had the same input, but got different outputs. So basically, if we have a function, we have a good working machine, that for every input, there is one output, okay? So it's just got to be working machine. So this one is not working. So let's take a look at another scenario. Same machine, but number 3 is a little bit different. It says that I pushed the blast button and I received a can of blast. Cool. Mrs. Traver pushed the second button for blast. So if you look at the picture, I have a blast for the first button and a blast for the second button. I pushed the first one, got a blast. Cool. Mrs. Traver pushed the second button for a blast, and she got a blast too. Is this machine functioning correctly? Constantly, right? Consistently. And that answer is yes. Even though we pushed different inputs, we still got the output that was associated with that input. So we are going to say, yes, this is a good working machine. We just pushed different buttons even though those buttons were the same. Okay, so let's say everyone that pushes the lemon twister, right? Everyone goes up, no matter who they are, they push the lemon twister and they got a slurp every single time. Is this machine functioning correctly? Now, I know you want to say no, but the answer is yes, and I'll tell you why. If every single time you push the button, you get the same thing. You push the button, got a slurp. Push the button, got a slurp. The input is the same. We're still pushing this button. Is the button labeled wrong? Yeah, probably, right? But it's still working correctly because every single student is still getting a slurp every time. So that's definitely a yes situation. Okay. Good. Every time we have the same input, the same button, we push the same button, we get the same output. They got the slurp every time. Okay, so now we got a little bit of a handle on what functions are. Great working machines. Think of a soda can or a machine, soda machine. So now let's think about it as a table. So I think it's very valuable for you to copy down these tables. Obviously, I say that in like every video. But so like this first row, this is our X, this is our input. And when you look at the tables, I want you to think about that's the button. I push button 7 and out comes a 6. So I think that's going to help if we kind of like write that down. So the X is the input and then the Y is the output. If you notice for this one, it says f of x. Good. So let's take a look and see, is this first table functioning correctly? So I push a 7, I get a 6, good. I see a -2, I see a 0, I got a 4, I push the 4 button, I get a 2, I push the 9 button, I get a 10. So looks like this is working pretty good. So I'm going to say that this is a function because it's functioning correctly, right? So I'm going to say, yes, this is a function. All right, now let's take a look at an example that's not a function, okay? Option, the second table. So I push a 3, I get a 4, I push a -1, I push a 2, I push a 0, I push a 1, I push a 2. Wait, hold on. So right away, I look at the buttons or the inputs or the X's, right? And I see that I have the 2's. I have 2 2's. Okay, so that means this person went up and pushed button 2 and they got a 9. Then another person walked up and pushed 2, but they got a -8. That's what makes this not a good working machine. That's what makes these lists of ordered pairs here, that is not a function because it's not functioning correctly. So a good strategy is to look at the X's and see if any of them are duplicated. If they are, then you have to look at the output and see if there are different outputs. So this is, this one is not functioning correctly. So it is not a function. Okay, so let's go back to like the vending machine with candy instead. So if you notice for the X's, this is our button number. And so we have 2 2's. We have 2 1's. And so if I push number 1, I get a stick. Cool, sticks. Then if I push number 1, I got a sticks again. So that's okay. See, this one had 2 2's. But I got a different output. When I pushed the 2 button, I got a 9. When I pushed the 2 button, I got a -8. If this was a -9, then it's a good machine, right? It's a function. So this is an okay situation. Now I pushed a 2, I got M and N's. I pushed the 4, I got M and N's. Still good, right? Because that's a different button. Still okay. I pushed a 2, I got M and N's the first time. I better get M and N's the second time, and I don't. I get duds. What that means is if you walk up to this machine and you push the number 2 button, you have no idea what's going to come out. Is the M&M's going to come out? Are the duds going to come out? You don't know. So that's why this is also not a function. It is not functioning correctly. It is not a function. Okay. How you guys doing? You doing okay? Yes? Okay. All right, so we're going to continue to look at functions, but now we're going to look at the graphs instead of the tables for a little bit. And this is an important part that I want you to write down in your notes. The relationship between inputs and outputs is a function if there's exactly one output for every input. All right, now this right here is the notation. Notation is like how we write things. That indicates a function, okay? And so far, we've been seeing, I'll give an example, like y equals 2x plus 1. And when we start to talk about it as a function, as a working machine, instead of the y, we're going to replace it with f of x equals 2x plus 1. Okay, this is just another way, the f of x is just another way that the reader, when they're reading it, they know, okay, this is a good working machine. This is a function. And so it's just kind of a different way to let the reader know that it's already a function. Cool. All right, so let's look at a table. Now remember, in the last one, our x's were our input. They were our buttons, right? We pushed this button and we got an output. So same concept with a graph. Take a look at the x's. If I push button 3, what comes out? -2. So like if you were to push button 3 and another one was up here, then you don't know if you're going to get a -2 or a +2. But we only have one. Now, old school, we call this the vertical line test, which means you could like draw a straight vertical line straight up and down through that like that x value. And if you only have one point, then you know that it is a function. And so sometimes, well, you're going to see me do that for sure too in some of the examples. But for right now, let's get real comfortable with the buttons and pushing them. So I push button 3, only this comes out. I push button 2, only the 3 comes out. I push button 1, 1 comes out. I push 0, nothing's there, right? And so there's only one dot every time you think about pushing the button for x. So that means that this is a function. Okay, so let's take a look at the second graph. So let's say I push button 1, right? Here's x, my input, button 1. What could come out? What's my output? Well, it could be this right here. Could be this value right here. Could be up here, like a +2 could come out. There are 3. So let me draw that vertical line right through 1. I'm going to do like a dashed. And it hits here. It's here. And that's here. Which means now, if I push button 1, I could get 3 different possible outputs. And so that's what makes this not a function. All right, let's do one more. Let's do one more. And let's look at both table and graph, which is what we did today. So table and graph, I want you to pause this video. I want you to look at both of these and I want you to decide function or not a function. Okay, let's see how you did. And we're looking at this graph right here. In this graph, if I push button -2, I only get one value. And it looks like the same for all the way across. So it looks like this graph here is a good working machine, consistently working, and it is a function. Okay, now let's look at the table. So this table here, I'm going to use my strategy. This is my input. So I'm going to look and see, are there any that are duplicates of each other? 7, -2, 0, 4, 9, -3, 6. It all looks good to me. And so that's super promising. And so, yes, we're just going to stop right now and we're going to say this is definitely a function. Yes. All right, so that's today's lesson for today. I hope you guys are having a great day. I hope that you understand functions just a little bit more than you did yesterday. And we're going to continue studying functions with the next video. And that's it. I'll see you guys next time. Bye.